Hi, so today I'm going to be going over problem number 3 of the Doppler effect and looking for Aunt Minnie. So problem number 3 is going to be based on the previous two questions in that section. And from those previous two questions, we know that there's a bat that's emitting sound at 120 kilohertz. We also know that there's a moth that's flying away from the bat at 2 meters per second. And then the speed of sound is going to be 343 meters per second. So the actual problem says the bat speeds up so that the frequency reaching the moth is now 123.6 kilohertz. How long will it take the bat to catch the moth if the moth is 3 meters away? So the first thing I did, which you can see here, is I drew a picture. So we have our bat right here emitting sound waves, and the bat's flying towards the moth. And the moth right here is flying away. And then because the bat and the moth are moving, we see a Doppler effect. The sound waves right here are shorter in wavelength than the sound waves back here. So because of the smaller wavelengths in front of the bat, the moth hears a frequency that's greater than the frequency emitted. We know this just from the equation where velocity is equal to the wavelength times the frequency. Because the frequency heard by the bat is greater than the frequency emitted, the bat's also moving faster than the moth. So right here, Vs, the speed of the bat, should be greater than Vo, the speed of the moth. So now from the problem, we have some given values. So we know the frequency of the bat that the bat's emitting, which is 120 kilohertz. We know the frequency that the moth hears, which is 123.6 kilohertz. The distance between the moth and the bat is 3 meters. And the speed of sound right here is 343 meters per second, and the speed of the moth is 2 meters per second. The only unknown value is the speed of the bat, and by finding the speed of the bat, we should be able to find the time it takes for the bat to reach the moth, being 3 meters away. So to do this, we use two equations, and they are right here. So using this equation, we can find the speed of the bat, and by finding the speed of the bat, we can find the time it takes for the bat to reach the moth by using this right here. So with this equation, we have to figure out what signs we're using. So this is the equation, and because the moth is moving away from the bat, the sign in the numerator right here is going to be a negative. And then because the bat is moving towards the moth, this is also going to be a negative. To make sure our signs are correct, we know that the frequency heard by the moth is greater than the frequency emitted. So this right here should be greater than 1 for right here, the frequency heard by the moth to be greater than the frequency emitted by the bat. So what we subtract on the bottom in the denominator should be greater than what we subtract on the top to get a value greater than 1. Since the velocity of the bat is going to be greater than the velocity of the moth, we know that our signs are right. So with this equation, I just rewrote it down here, and then I solved for Vs. So the first thing I did was I multiplied the frequency heard by the moth by the denominator, and I got this right here. After that, I divided the right side by the frequency to get this. And then after that, all I did was I added Vs to the right side, and I subtracted this right here. And then this was my final equation, and all I did was I plugged in all the numbers that we had before, our known values, to get a velocity of 11.932 meters per second for the bat. So now that we have a velocity, we can go to step 2. And for step 2, we just plug in the distance between the bat and the moth, which is 3 meters, and our velocity, which we obtained from above, and then we get the time it takes for the bat to reach the moth. And our final answer is going to be t equals 251 thousandths of a second.